All right, guys. So we are going to do our first density lab today. There are several pieces of equipment that we are going to need to use today. So let's talk about them one by one. So I have uploaded this as a PDF document if you want to follow along for those of you who are at home. The first piece of equipment that we are going to use is our balance. So a balance is one of these. Now, a lot of people will call these scales. In chemistry, we don't call them scales. We call them balances, okay? The next thing that we are going to use, we are also going to use graduated cylinders. Today, we are actually going to use two. We're going to use a 10 milliliter graduated cylinder. Now, if we look really carefully, and I'm going to put my hand behind so you can see the lines, these lines will go to the 10th of a milliliter. This is a 10 milliliter graduated cylinder. So we can estimate in between those 10th lines to get to the 100th. This is a 50, or actually 100 mil graduated cylinder. Each of these lines are worth a milliliter. So we can get to the 10th of a milliliter. So this will go to the 10th. This little one will go to the 100th, okay? Now, if you remember, graduated cylinders, water does not go straight across. It kind of, this graphic does a good job. It creates an arc, and that arc we call a meniscus. So every time we read a graduated cylinder, we are going to read at the bottom of the meniscus. That makes it consistent, and that's how we are going to read, okay? And then the last piece of equipment that we are going to use is your classic ruler. Now, we are going to make sure that we use the centimeter side, okay? In science, we always use the metric system, so we're going to use the centimeter side. The thing that we have to be really careful about when we use this ruler is notice here, the 0 is not at the very end of the ruler. Make sure that you use the 0 mark here that's a little bit into the ruler as the 0 part when you're putting it on an edge, okay? So make sure that you're using that 0 placed correctly. All right? So the first thing we are going to look at is the density of some distilled water. Now, I have some distilled water in these blue squeeze bottles, and we are going to make sure that we use the distilled water here, okay? So the first thing that we have to do is we need to measure the mass of a dry cylinder. You'll notice that I have some drops of water in here. Don't try and dry it out by putting some paper towel or some Kleenex or tissue in here because you won't be able to get it back out. Sometimes our equipment isn't as dry as we want because the last class was there or whatever. We're going to just do the best we can with what we have. You might want to try and shake it out a little bit if you can, but notice these drops don't really leave, okay? So I am going to put this on the balance, and I'm going to grab the camera so that you can see what we've got. We have a balance of 30.25 grams. So we are going to write that down, 30.25. Actually, yeah, 30.25. All right, now I am going to take this water and I am going to fill this up to as close to the 10 milliliter mark as I possibly can. Now, because water and glass kind of bend the light, we want our eyes to be right where the water is. So I'm going to kneel down and see if I can get a better measurement here. And this guard is to, when it tips over so that it won't break the glass, this guard right here protects the glass. So you can move the guard up or down depending on what you want. Okay, I'm going to very carefully and slowly put some water in here, and I'm going to try and keep my water along the side so it doesn't create bubbles. Because bubbles are not what we want to measure. We want to measure the water. So I'm going to put my hand behind here so I can see the lines a little bit better. I think that I'm right there on 10.0. So 10.00 is going to be my volume. And I am going to take this here so that you can see what I'm talking about. If I look at that, I'm right at 10.00, where that meniscus goes. Now I'm going to take this and put it on the balance and see what we get. We get 40.11. So I'm going to put down 40.11. So there's the data that you should have for the density of water. Now I can get the mass of the water by taking this initial mass and subtracting it from the final mass. So if I get the difference here, I will get the mass of the water. The volume of the water is already given. So remember, density is mass divided by volume. So you should be able to have all the data right there that you need. Okay, so we're going to do the next step, which is the density of a water solution. So this water solution, we are using a copper 2 sulfate water solution. I use copper 2 sulfate just because it is blue and it helps you differentiate between the water. So we're going to still use this 10 milliliter cylinder. So take this water and just dump it in the sink. And shake as much out as you can so that you can get the cylinder as dry as you can. Okay, notice it's not going to be perfectly dry. That's okay. Okay, so the first thing we have to do is mass this cylinder again. And this time I get a mass of 30.26. So I'm going to write that down, 30.26. And then I need to fill the cylinder with the blue solution. So here we go. I'm going to fill this with the blue solution. And once again, I'm going to try and pour this as carefully as I can down the side so it doesn't create bubbles. And I'm going to try and get as close to 10 mils as I possibly can. So when I look at that, yep, I'm right on 10.00 mils. Let me show you what I mean. That meniscus is right there at 10.00. Okay, and I'm going to mass this again. So I get a mass of 40.57. And I have a volume of 10.00. Okay, so once again, you can figure out the mass of the solution by getting the difference between those two. And with the volume, you can get the density. Now we're going to work on the density of the wood block. So here we go. I've got a wood block right here. And we're going to do the length, the width, and the height. Now remember to use the centimeter side. So here we go, length. Make sure you're using it from the 0 mark. So I have, let's see, 14.9. So my length is 14.9 centimeters. My width, let's do the width. I have 5.93. And height, let's look at the height here. I have 2.9 on the height. 2.9 centimeters on the height. So just so that you can get those, I'm going to put those there. And then the next thing we've got to do is we've got to mass the block. So I'm going to take the cylinder off the balance, make sure the balance reading 0, put the block on here, and we get a mass of 112.93. So here we go, 112.93. Okay, so all your data is right there that you need. So you can get the volume of the block by multiplying out the length, the width, and the height. And we have the mass, so you can calculate the density. The last thing we need to do is get the density of some shot. So in order to get the density of the shot, we're going to have to use what is called a weigh boat. So when we use a weigh boat, we're going to put that weigh boat on the balance, but you'll notice that the balance no longer is reading 0. And that's a problem. We don't want to weigh this weigh boat. We just want to weigh the shot. So you'll see that we have this on and 0 button. So we're going to 0 this. Sometimes it's also called a tare button. Now it's reading 0, even though we have this weigh boat on the balance. Now we can grab a handful of shot and put it in here. So I am going to grab a handful of shot. I'm going to show you what it looks like. We're going to put it here on the balance, and we're going to get the mass of that shot. So the mass of that shot is 15.56. So we're going to write down 15.56 for the mass. And next, we've got to get some water in the graduated cylinder, and we're going to use the larger one here. Okay, so I'm going to just fill it up with a little bit of water. It doesn't have to be anything specific. Okay, so I just filled it up with a little bit of water. I'm going to put this down so it's level so that I can read it. Now, each of these lines are worth 1 milliliter. So I have 45 point, it looks to me like 45.8. Yep, 45.8 mils. So now what I need to do is I need to put this shot in the graduated cylinder, but I don't want to just dump it in because sometimes this metal is really heavy and I don't want this to fall through the water and crack the glass. So what I'm going to do is I'm going to tip this and I'm going to gently put this shot in here so I'm not cracking the glass. And I don't really want to splash either because I want the water to be at the bottom. Now I'm going to read my new volume. And the difference in this volume is going to give me the volume of the metal shot. So if I look at this, I've got 51.5. So my new volume is 51.5 mils. Okay. So getting the difference between these two, I can get the volume of the metal shot. And we have the mass of the metal shot here. So I can calculate with that the density of the metal shot. I want you to take the density that you calculate and compare it with the densities here and give your best guess as to what metal you have. And then try yourself with this bonus question. All right, have a great time. We'll talk to you later. I hope you enjoyed this lab.